1000 rupees balance in your account. That means the state before the transaction is consistent. That means it shows 1000 rupees as balance, which is consistent. That is called as consistent state. So before the transaction begins. Now, when the transaction starts, or let's say initiates, the database will be temporarily goes into inconsistent state, and this particular period of execution of transaction, the database will be in inconsistent state, and once the transaction is completed, for example, that 800 rupees is transferred successfully into your friend's account, so the balance shows that 200 rupees in your account, and your friend's account balance will be added with, let us say, 800 rupees. So that means in both the accounts, your account and your friend's account, the amount shows correctly. So that means those states are actually called as consistent states. So consistent states before the transaction and consistent state after the transaction. So that means at the end of the transaction or after completing the transaction, once again the database comes into consistent state successfully. Okay, so this is very, very important as far as this timing diagram is concerned. So this is another example of e-commerce, how the transactions takes place. Let us consider the example of placing an order in Flipkart or Amazon. So these are the operations that takes place. You can see the transaction start, selecting the item or product, selecting if the payment method, if it is net banking, then select the bank, enter the user ID and password, approve the amount, enter the high security password, checking the amount payment is useful or not, and return to the website and transaction completed. So this is actually an example, another example which shows how a set of logically related operations will constitute a transaction. Similarly, another example, that is withdrawing an amount from the ATM. This example already we have been discussing right from the beginning of this lecture, how using an ATM card, how let us say the amount is actually deducted. Okay, so a set of logically related activities. So this is another example. So some popular examples of transaction processing have been given here. The famous example is ATM transaction of a banking activity. Next, credit card authorizations. This is another example where the transactions are being performed. Next, online bill payments. It may be credit card bill or let us say electricity bill or whatever it may be. Next, self-checkout stations at grocery stores. Then trading of stocks over the internet and various other forms of electronic commerce, e-commerce, just like placing orders using Amazon or let us say what we call Flipkart. Now, let us focus our discussion on what are the issues that are being faced on a database or let us say the users, especially while a transaction is being performed. There are certain issues, actually we should call them as problems. There are some problems during a transaction. So what are those problems? What are those issues? So there are certain issues or problems. So let us see one by one. First issue is failure of operations in the middle of a transaction. What is meant by this? Let us consider an example of ATM transaction that is being done in a particular ATM machine. Suppose if you want to withdraw some cash using an ATM machine in a particular banking for a particular banking activity, let us suppose that suddenly a power cut failure or let's say power failure happens, or let us say the ATM machine system crashes. So automatically your transaction of withdrawing the amount or depositing the amount may not occur, may not happen. So this is a serious problem that can leave the database in an inconsistent state, because if the transaction is not completed, automatically the balance amount that is being there in your account will show some wrong figures, and at the same time the database will be moved to a or will shown into, let us say, an inconsistent state. So same like that entering the after entering the PN, let's say PIN number, you can see here. Assume that the transaction fails after entering the PIN number in ATM, then the account statement shows that the amount is deducted from the account, but we won't receive the cash from the machine outlet, or our friend will not receive it. This is called as the inconsistent database. Normally, this kind of scenarios are being faced these days through ATMs also. Practically, we have been experiencing these issues. Sometimes during, let's say in the middle of, let us say, ATM transaction, suppose maybe due to the system failure or system crashes or power failure, so you won't get the cash from the ATM, but the database shows that it is updated and the cash is disbursed. So this is actually called as a temporarily inconsistent state of database, but automatically there are some recovery techniques. There are some recovery techniques which restores the original database or original consistent state. Okay. So second issue is ensuring the data consistency before and after the transaction. Ensuring the data consistency before and after the transaction. So what's meant by that? For example, for amount transfer transaction from account A to account B, which the example we are discussing right from the beginning, then the total should be the same before and after the transaction. The balance should be same. Balance should be correct, rather. The balance should be correct before and after the transaction. Suppose you have 1000 rupees in your account and your friend has 2000 rupees in his account, and if you want to transfer 800 rupees from your account to your friend's account, so before the transaction your account should show a balance of 1000 rupees, and after the transaction, let us say your account balance should show only 200 rupees, because you are transferring 800 rupees to your friend's account, and your friend at the same time your friend's account will show 2000 rupees plus 800. That means 2800 rupees should be the balance figure that should be seen from your friend's account. So this is actually called as consistent or consistency, data consistency before and after the transaction. But sometimes this particular consistency may not be achieved, may not be established due to some problems. So this issue has to be maintained, this issue has to be preserved. Next one is handling concurrent transactions. So what is meant by this? Handling concurrent transactions. When simultaneous operations are being done, simultaneous transactions are being done on a particular database, then they should not be, let us say, interfere with other transactions. So what is meant by that? For example, let us suppose that I have a car loan and I have a house loan and also some personal, three loans are there, and all these three loans are going to be, the amount is going to be deducted for all these three loans on a particular date, let us say 10th of a particular month. So that means on 10th of every month, let us say that these three loans amounts or loan amounts have to be deducted from my account. Okay, three different loans have to be deducted from my particular account. Okay, so simultaneously, let us say 10 a.m. at the same time, let us say 10 a.m. at the same time, all these three transactions have to be completed on 10th of every month, let us say. So while performing all these three transactions simultaneously at the same time, each transaction should be conducted or should happen separately without interfering with the other transaction. So this is actually an important point, where when simultaneous transactions are being done, this one transaction should not interfere with other transaction. So this is nothing but establishing the concurrency. So this concurrency handling or concurrent transaction should be handled properly. So next, once a transaction completes successfully,